start from the application about the vector function. If you are an engineer, you want to design this kind of block, you need to do the calculation. How much glasses you need to use to design this kind of block. You need to know all the diameter, you need to know the length. So materials density, and also how many turns, the spiral turns, you need to design. So you need to use the vector function to help you to do the calculation. The first one, we learn functions. So of course, you need to find the domain. Okay, and then we can have the pre-assessment first. Okay, so just a simple questions, and you can just take a guess. Okay, so look at the sequence. An example to test to check if you understand the difference between the limit applied to sequence and series. Right. Alright, time's up. So let one to share your answers to us, okay? Ready? Limit is at 1/2, so for sequence, for series is convergent or not? It's divergent because the limit is 0.
We draw the xy plane and the points. So we find out the range of x and y. Y is between 0 and 2x, and x is between 0 and 2.
Executions questions. For example, the reason why we need to times 2.
It's a it's a complete sphere, but we only discuss the hemisphere first. So the one we need to times 2 is.
Oh, okay, very good. Okay. Before we end these sections, we can have a pause assessment. But after you may just explain on the answer. So what about the second question? Me, Francis. Okay, Ethan.
Okay. This need to pass through the origin 0, 0, 0. Yes, so if it passes through origin, we can find a value of t that make 2t equal to 0 and 3 minus t equal to 0. But we can't find the value, so it is not passes through the origin.
It's not, right? Because you can't find a t.
Yeah.
So that's what?
That passes through the origin.
Okay, so the origin. Okay, the origin. Recap for the section for 15.1. Okay, so section 15.1 we have learned the definitions of double integrals. Okay, the first steps you can apply the first step to define the double integrals. Okay, 分割取样求取极限 the first steps. Okay, alright. So simply put, you can say that the limit of the Riemann sum be defined as double integrals.
And the most important thing is that when you differentiate or integral a function, and the半径will not change, but the boundary point might change. So you need to put the boundary point back into the equation and double check if it changed or not. And here is our whole chapter. Thank you.
Hello everyone, and this problem is need to find the Maclaurin series of fx. The first step is if x not equal to 0, and we can get fx is equal to x minus sine x divided by x power of 3. So in this part we can see that sine x can rewrite to the sigma form. Okay, so the sigma form of sine x is equal to sigma n equal to 0 to infinity, and this, so if the x equal to 0 and all of this will go to 0. Okay, so we can see that f0 is equal to 1 divided by 6. Okay.
Okay, good morning everyone. Welcome to the final class of this semester. Okay, so today is your show time. Okay, so you will have the mini PPL with the SDGs. Okay, so you should be able to connect the calculus to real life. Okay.
Hello everyone, we are Group 5, and today we are going to talk. Our topic is the sweet spot, which is about the problem of overfishing. And this is our teammates, and today we are going to use calculus to identify the maximum sustainable yield. And we are going to use the calculus concept of derivative optimization and the differential rule. And our whole topic is about the SDGs 14, which is about the life below water. Today we are going to talk about and how to know the limits, or how many fish should we catch to contain the surrounding to become sustainable use. And we can have every year we can have a sustainable amount of fish to catch. And we use derivative optimization rule and the differential rule to find the slope on the PM, and to find this graph to get the maximum rate of the fish change.
Also inspiring presentations. Congratulations to Group 2. Alright. Okay. So this will be the judge going over Group 9 and Group 5. Okay. So Group 9, I would like to say thanks for your hard work and thanks for you sharing your creativity